In the previous video, we proved that if a function is differentiable, then it is continuous. In this video, we're going to see two examples that show that the converse is not true. So let's get started. So first, we're going to look at the function absolute value. The function absolute value of x is not differentiable at 0. And just do that, to check that that is indeed the case, we just need to look at the definition. You see, f of 0 plus h minus f of 0 over h is the absolute value of 0 plus h minus the absolute value of 0 over h. And this is just the absolute value of h over h. Now, if x is positive, this is 1. And if h is negative, this is negative 1. That tells me that the limit as h approaches 0 from the left is going to be negative 1. But the limit as h approaches 0 from the right is positive 1. So the limit just does not exist. And if we look at it, what happens here, we look at the graph, we have an abrupt change on the slope of the tangent line. We look at this and then we break like that. This is a very abrupt change. We have here like a corner. So whenever we see the graph of a function, if we see a corner that they want, like the one we see here in the function absolute value, that will force our function to not be differentiable, because the left and the right hand side limit are going to be different. Now let's take a look at a different example. We have the cube root of x. This one is not differentiable at 0. And let's see why. Again, we're going to create this quotient that we need to study for studying differentiability. So f of 0 plus h minus f of 0 over h is just cube root of h over h. So this is 1 over h to the 2/3. But you see, when h approaches 0, this will go to infinity. And, well, that means that the derivative doesn't exist, so my function is not differentiable at 0. And at x equals 0, what happens is that the slope of the tangent line becomes infinite. That means that we have a vertical tangent line at the origin. And my graph looks something like that. So whenever we see from a graph that my function has a vertical tangent line at a point, that again tells us that my function is not differentiable at the point. So to summarize, how can a function fail to be differentiable? Well, there are three ways in which we can have that failure. We can have a corner or a cusp, like something like look like that, an abrupt change in the slopes of the tangent lines. We could have a vertical tangent line or simply be discontinuous. These are the three ways in which a function can fail to be differentiable.